Hi guys, welcome back to NerdNarrative. This channel is about real growth in tech, especially in data analytics. If you are a fresher trying to enter data analytics or someone experienced trying to switch or level up, you'll find practical, real preparation content here. We are going to learn, improve, and prepare together. Welcome to NerdNarrative. So, today's video is SQL. Now SQL is a big topic. So I've divided into two videos. This is part 1. In this video, we'll cover 3 things. Number 1, joins. Full outer join, inner join, left join and right join. Number 2, subqueries. What they are, where you use them and real interview questions. CTEs, common table expressions. How they work and why interviewers love asking about them. And at the end of each topic, I'll give you the exact interview questions companies ask, so you know exactly what to prepare for. Alright, let's get into it. We'll get into DB Fiddle, which is free, to dbfiddle.com, which is free, so you can use that to write these queries. I'm writing there. So I won't type because video gets too long. So I have already done that. So I'll just copy paste them and I'll explain you in detail. So before we write any join queries, we need sample data to work with. I have created 2 tables here, employee and department. Employee table has 5 employees and department has 4 departments. Now notice this one carefully. Kiran has null in department ID column. That means he has no department assigned, and marketing has no employees at all. I've done this on purpose because these nulls will show us the difference between join types very clearly in a moment. Next, let's first just look at our raw data. Now we are going to write select queries in query SQL. Select star from employee shows all 5 employees, where select star from department will show all 4 the departments. Keep this output in mind because after every join we run, I want you to compare the result back to these 2 tables and understand what changes. Okay, first join is inner join. The rule is simple. Inner join only returns rows where there is a match in both tables. So when I run this, let's count the result. We get Ravi, Priya, Arjun and Sneha. That's 4 employees. But wait, we have 5 employees in our table. Where is Kiran? So Kiran had null department ID, so he has no matching department. Inner join excluded him completely. And marketing also gone. No employees in marketing, so no match, not in the result. This is the key thing about inner join. If there is no match on either side, that row will disappear. So when interviewer asks about what is inner join returns only rows with a match in both tables. And left join. Now left join. This one is different. Left join says give me all rows from the left table no matter what. The left table here is employee table, right? So all 5 employees must appear in the result. When I run this, now we see all 5 rows including Kiran. But look at Kiran's department name column. It shows null. That's null join saying I couldn't find a matching department from Kiran, so I am showing null instead of dropping the row. Marketing still doesn't appear because it's on the right side and has no match, so left join keeps everything from the left, fills nulls where right side has no match. Most common interview Follow up. Write a query to find employees with no department. Left join plus where. D dot department ID is null. Okay, you want to write like that. Next, right join is exactly the opposite of left join. So now it's a right table. Department is the right table that gets all its rows written no matter what. So all 4 departments must appear here: HR, IT, finance and marketing. When I run this, marketing appears in the result now, but the employee name shows null because marketing has no employees. Right join shows it anyway and puts null for employee name. And Kiran is gone now because he has no department and is on the left side. In practice, most developers just flip the table order and use left join, but no, right join exists. Interviewers will test this. Fill outer join using union. Now fill outer join. This one returns everything from both tables. MySQL doesn't support full outer join directly, so we simulate it using union of left join and right join. Okay, when I run this, both Kiran and marketing appears in the result. Kiran shows null for department name. Marketing shows null for employee name. This is full outer join. No row is left behind for either table. In real work, you use this for data reconciliation, finding records that exist in one system but not the other. Interview tip. If asked about full outer join in MySQL, mention the union workaround shows real world knowledge. It shows the real world knowledge. Okay. And now subqueries. We'll get into subqueries. A subquery is simply a query inside another query. Think of it as asking 2 questions at once. In a query, what is the average salary of all employees? Outer query, show me all employees earning more than that average. So the inner query runs first. It calculates the average. Then the outer query uses that number to filter. When I run this, we get Priya, Arjun and Sneha. These 3 earn above the average. Without a subquery, you need to separate queries. You calculate average first, then filter. Subquery does it in one shot. And next, this is problem, the single most asked SQL question in every data analytics interview. Find the second highest salary. The logic is, inner query finds the max salary, which is 80,000. Outer query then finds the max of everything that is less than 80,000. So the second highest salary is 70k, which is Priya's salary. Simple, clean, works in every database. Always mention distinct when discussing this, in case 2 people have the same salary. Okay. Now, this is the second method for the same problem and it's clear to read. Order by salary descending, sorts from highest to lowest. Limit 1 says give me only 1 row. Offset 1 says skip the first row, which is highest. So we skip 80,000 and return next one, which is 70,000. Distinct is important here. If 2 employees have the same salary, it will still give the correct second highest. This method works in MySQL and PostgreSQL. For SQL Server, use stop and offset fetch instead. Mention both methods in interviews. It shows you multiple approaches to the same problem. Now, a subquery in a from clause. This creates what we call a derived table. The inner query calculates average salary per department and gives it in a name department average. Then the outer query treats department average like a real table and filters it. Only departments where average salary is above 60,000. IT department has Priya at 70,000 and Arjun 60,000. Average is 65,000. Passes the filter. Finance has only Sneha at 80k. Average is 80k. Also passes. HR has only Ravi at 50k. Average is 50k. Filtered out. This is very useful when you need to filter an aggregated value after growing. The alias as department average at the end is mandatory in MySQL. Always name your derived table. Now CTEs. Common table expression. This is where it gets interesting. A CTE gives a subquery a name. So you can use it like a table. See the with keyword at the top. That's how every CTE starts. Average salary is a name I gave the CTE. It calculates the average salary. Then below, I use average salary like a normal table in my main query. The result is the same as the subquery version we did earlier, but look like much cleaner this reads. This is the real power of CTEs. Complex logic becomes readable step by step. Interviewer answer. CTE. It's named, reusable, readable. Subquery equals to inline. Repeats if used multiple times. Run the subquery version and CTE version side by side. If interview wants to share a screen, try to run them and run them if they ask for a subquery version or a CTE version. Try to, if they ask the difference, make sure you explain both of them so that they will get to know that you have different approaches and more knowledge. And this is the query that impresses interview. Two CTEs work together. First CTE, department average, calculates average salary per department. Second CTE, high paid, filters employees earning above 60k. Then the main query joins these two CTEs together. Notice the comma between two CTEs. That's how you chain multiple CTEs with keyword. Once at the top, the common between each CTE. The result shows high paid employees alongside the department's average salary. This tells you not just who earns high, but how much above their department average they are. That's the kind of insight a data analyst is expected to produce. Not just running queries, understanding what the output means. This type of multi-CTE queries comes up in a senior DA in data engineering interviews. Practice until it feels natural. So that's all the queries for today. We covered inner, left, right and fuller out joins with real data. We wrote subqueries in 3 different places, where, from and self clause, and we use CTEs single and multiple to write clean, readable interview ready SQL. Now here is your homework. Run every single query yourself in DB Fiddle. Modify the data, add a new employee, change the salary, and see how the output changes. Try writing the second highest salary query without looking. Write a CTE to find employees earning above their department average from scratch. Drop your answer in the comments. I'll reply to every single one next video. Window functions and query optimization. See you there. Bye bye.